Hi, this lesson we will look at continuous random variables. So what does it mean by continuous random variable? So first thing, a variable x, it can take different values, right? So what does it mean by continuous? Is a variable that can be measured, right? So a random variable can assume in any value contained in one or more intervals. So example, height of a person. Let's say a person's height lies in between 150 to 170 cm. Okay, so this person's height, it can be a continuous random variable. Let's say this person's height is more than 157 cm. Is it possible? Yes. Okay, or can this person's height to be 167.23? Yes, right? Can take any value in the interval. So why do we call it random variable? Because when the x is a value 157 or more than equals to 157 is depending on probability. All right. Or we have other examples like time taken to complete an examination or weight of a baby. Okay, so these are the variables you can measure and it depends on the probability. Okay, a graph fx representing a continuous random variable is the probability density functions, PDF. So the PDF has the following properties. A, it cannot be negative since you cannot have a negative probability, right? So it has to be greater than equals to 0. And B, total probabilities, as we learned before, it must always be in between 0 and 1. So total must be equals to 1. That means for the functions, if we integrate from the lower limit until the upper limit, the area under the graph must be equals to 1. Let's see an example here. Fx, right, is defined as half x, a straight line functions, and is only defined in between 0 and 2. Okay, let me sketch the functions. So when the x is 0, the y is 0. When the x is 2, the y is 1. So we can get these straight line functions. So this is a PDF. Now refer back to point A, it cannot be negative, which means you will see the function lies above the x-axis. Okay. Then second, total probability must be equals to 1, which means if I'm going to find out the area under the graph from 0 until 2, right, I will get the probability and it must be equals to 1. Okay, the area under the functions will give you the probability and hence total area equals to 1. Okay, so these are the important properties of the PDF. Okay, note in many situations the data are defined across specified intervals. So anything outside will be 0, right? What does it mean here? Means according to my example, the function is only defined in between 0 and 2. So anything other than 0 and 2 will be 0. Otherwise, okay? So that means if I'm trying to find, is that possible that x equals to 3 here? A value of x that is not within 0 and 2. So obviously probability is 0. Okay? Or maybe x less than equals to -1 is also going to be 0. Okay, let's see the example here. X is the continuous random variable, the mass in kilograms of a substance produced per minute in an industrial process. So the PDF given, right, you can see is a quadratic function and is only defined within the interval 0 and 6. Anything else, 0 otherwise. Okay, what does it want for part A? Shows that the probability of X in between 0 and 6 equals to 1. Like I emphasized just now, the property of PDF. If you are going to integrate it from 0 to 6, the lower and the upper limit of these functions, then we're supposed to get a 1 because the total area under the graph is the probability. So I multiply in the X, multiply in. Okay. So let's see, we quickly carry out the integrations. And then we sub in the limits. All right, you can press calculator and manage to get this. And yes, it is equals to 1, like I mentioned just now. So this is a valid PDF functions within the interval 0 to 6 of the functions. It will give you a total probability, which is the area under the graph, equals to 1. So now we got to make use of this PDF to find the probability that the mass. So the probability of the mass less than 5 kg. So how do we use this PDF to find probability for X less than 5? We are going to integrate. Okay, so what are the limits? So since we want the X less than 5, means that we'll look from 0 until 5 because the lower value here, the lower limit here is 0. So we integrate from 0 to 5. Okay, of the PDF. So when we integrate this, we will find out the probability for the X, the mass of the variable less than 5 kg. Okay, so we integrate and then we sub in the limits. Okay. So let's use calculator and find out the value. Okay, we found this. And then, so this is divided by 36. And that will be the probability, 25 over 27. Or since it's a probability, we can keep it as a decimal number, round off to 3 significant, 0.926. All right, so we get to shows that the total area under the graph for the PDF equals to 1, which is giving you the probability. And we can use it to find the probability by integrating the PDF. Now we have a lot of partial questions. Okay, this is a questions from October, November 2005. And last time we call it paper 7, right? Step 2, paper 7, question 5. So it's telling you the continuous random variable x has the probability density function, PDF. Okay, given by this. As we can see from here, this is a linear function and it's only defined between 1 and 2. Anything else, 0. So a is a constant. Part 1 shows that the value of a is half. Okay, so we try to use the property we discussed just now. As we know, this is a PDF function, which means if I'm going to integrate from 1 to 2, right, the lower to upper limit of the PDF functions, it must be equals to 1. All right, again, this is a PDF. Hence, with the limit given, if we integrate the total area, and which is the probability, it must be equals to 1. Okay. So we start to integrate it. Okay. So we've done integration and we sub in the limit. So x is 2 to a. Okay, so now we calculate 2a minus a is just a. 4 over 6 minus 1 over 6 is 0.5. Okay, so finally the value of a equals to 1 minus half. It is equals to half. So we are going to show that a equals to half, then we have shown. Okay, part 1 done. Now we're answering part 2 to find the probability that x greater than 1.8. So in order to find probability, what should we do? We are going to integrate. So as this case is looking for x greater than 1.8, hence the limit will start from 1.8 until where the upper limit is 2. So we integrate from 1.8 until 2. Okay, of the PDF. And a value is a half. We sub in and 1 over 3x dx. And now, once we found the integrations value, we found the probability that x greater than 1.8. Okay? So, do the calculations now. Right? So just calculate the value. Okay. So found the value 17 over 75. Or you can put your answer as a decimal number 0.227, round off to 3 SF. Okay, so we found the probability. So these are the workings we need to do when we are answering questions about PDF. Okay, let's see the next questions. Okay, so let's see this partial question from May, June 2010 from the variant 7.1, question 5. So you have a random variable is defined as capital T, the time in seconds for which a firework burns before exploding. The probability density functions of T is given by, and you can see is given an exponential function here, and it's only defined between 0 to 5, right? Anything else, otherwise is 0. Okay, so we are going to show that k value equals to this. So what should we do again? Like this is a PDF. Hence, if you integrate from the lower to upper limit of the functions, you must get total equals to 1. Okay, so that is the important property of PDF function. Okay, now we are trying to integrate these exponential functions. Right, when you integrate exponential function, you will still get back the exponential function and divided by the constant 0.2. All right, done. Now we put in the limit. And the value 1 over 0.2 is actually a 5. So you're getting 5k e to power 0.2 times 5. Okay, minus 5k e to power of 0.2 times 0. So you are getting 5k e. And this one is anything to power of 0 should give you a value of 1. Okay, minus 5k. So can you see we can factorize the 5k? Oh, we can actually just keep the k at the side. So we should have a 5e minus 1. So k equals to, this is a 5. And then we can factor out the 5, and that is why we get to here, shown. Okay, so we found the value of k. Now, part 2, we are going to sketch the exponential functions, right? So the fx looks like this, where the k is this, and then e to power 0.2 t. Okay, so what is exponential functions? When the power is a positive value, then it's supposed to be a growth. Okay, and it will be going up from here until here, right? The limit 0 until 5. 0 is here. 5. Okay, so where does it cut on the, this one should be the t-axis. And this is the fx. Should be ft. Okay, ft. Right, where does it cut on the y-axis? When the t is 0, this is going to be 1 over 5 and e minus 1. Okay, so this is the PDF functions we get. So now we look at question part 3. 80% of fireworks burn for longer than a certain time before they explode. Find this time. All right. According to the questions, it means that 80% in this case means the probability, right? So we refer to the curve that we have sketched in part 2. 80% burn longer than certain time. So we are expecting here, let's say the certain time is small letter t. So 80% of it, right? This is the 80%. So which means we are going to find the probability that the time more than the small letter t and is equals to 0.8, right? 80% longer than, so more than the t. So at the same time, it means that here is going to be 0.2. Okay. So instead of using t greater than small letter t, we can also say that the t time less than the small letter t is equals to 0.2. Okay. So what are we trying to find? We are trying to find the small letter t value, right? Find this time. Okay. So now I'm going to integrate. So less than t. So according to the PDF, the lower limit here is 0. So which means I'm going to integrate from 0 until the small letter t of the PDF. All right, then it equals to 0.2. Okay, now we just continue to integrate it. All right, then we sub in. Okay, as we know, anything to power 0 will be 1. So what can we calculate? All right, so we calculate out this value. And you can see that k value is 1 over 5 times e minus 1. So you can sub in the value and do the calculations to find that the value is going to be 1.344. Then you put ln both sides. Let's use calculator. Zero point 29565. And finally, we found the t equals to 1.478, round up to 3SF, 1.48. All right, so we found the time. So you see these questions, probability is given and get back the small letter t value for this particular time. Okay, so that is the answer for part 3. Right, That's all for this lesson. Please like the lessons and subscribe to the channel. I see you in the next. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.